Hello, my name is Sakshi Gaikwad and currently I am pursuing MTech IT from IIPS DAVV. This is part of my analysis and design of algorithms assignment. In this video, I am presenting solution of internal test 1. In first question, we have to simplify following recurrence relation to find its time complexity, space complexity and power complexities. Time complexity may depend on various factors such as specific inputs to the algorithm, the efficiency of implementation, and the use of auxiliary data structures, algorithms. In practice, the actual running time of an algorithm may also be affected by various external factors such as hardware limitations, operating system, overhead, and size of the input. Here is the following time complexities of algorithms. Space complexity. Space complexity may also depend on other factors such as implementation details and specific inputs to the algorithm. In some cases, the space complexity may also be affected by use of auxiliary data structures or temporary variables. Following are the space complexity of following algorithms. Power complexity. Power complexity of an algorithm is measure of how the algorithm's running time grows as the input size increases. It's typically expressed in terms of exponent in running times, big O notation. Note the power complexity of the algorithms are not the same as the time or space complexity. The time and space complexities may have different constants or lower order terms that affect the actual running time and memory usage of the algorithm. Following are the power complexities of the algorithms. Linear search, the recurrence relation of linear search is given. We solve this recurrence relation with Master's theorem and calculate the space complexity order of 1, power complexity order of n, and time complexity order of n. Next is binary search. Its recurrence relation is given and its calculated time and space complexities are time complexity is order of 1, same space complexity is also order of 1 and power complexity is order of log n. For factorial function, time complexity is order of n, space is order of n and power complexity is also order of n. Now Tower of Hanoi problem. Its recurrence relation is given. It is solved by substitution method in following manner. Its calculated time complexity is order of 2 to power n, space complexity is order of n and power complexity is also order of 2 to power n. In the same manner, we have solved other recurrence relation also and find their time complexity, space complexity and power complexities. We have calculated complexity of binary tree traversal, quicksort, Strassen's matrix multiplication, Karatsuba integer multiplication. Second question is write recursive algorithm for polynomial representation. This algorithm defines a class polynomial with a constructor that takes a list of coefficients and evaluates the method evaluates the polynomial for a given value of x. The base case of the recursion is when the polynomial has 0 degree and it is a constant polynomial. In this case, the method simply returns the single coefficient. The algorithm works by breaking down the problem evaluating a polynomial of degree n into the problem of evaluating a polynomial of degree n minus 1. It uses fact that polynomial of a degree n can be expressed as p of x equal to x into q of x plus c, where q of x is a polynomial of degree n minus 1 and c is the highest degree coefficient. This allows the evaluation to be performed recursively by computing q of x and multiplying by x and then adding the highest degree coefficient. This is the algorithm of polynomial representation. Here we have class polynomial which has a constructor, function evaluate which evaluates the polynomial for a given value f x. Base case is constant polynomial n equal to 1, and the recursive case is given which evaluate recursively for smaller degree. Third question is write iterative version of Tower of Hanoi problem. This implementation uses a stack to keep track the recursive calls that would be made in the recursive version. The stack starts with the initial call to move n disk from row to row, using the aux rod as an intermediary. In each iteration of the loop, the top call is popped from the stack and executed. If there is only one disk to move, it is moved and the loop continues. Otherwise, two recursive calls are pushed into stack, one to n-1. Disk from rod to aux rod and in another move to n-1. Disk from aux rod to rod. Finally, the call to move the removing disk from rod to rod is also pushed onto stack. This process continues till stack is empty, at which point all the necessary moves have been made to solve the Tower of Hanoi problem. Following is the algorithm for Tower of Hanoi problem. It has a function Tower of Hanoi which create a stack and push the initial values. The loop is work until the stack is empty. If there is only one disk to move it and continue. Otherwise, push the two recursive calls into the stack. Thank you.